fabulous! What an event! What a great showing! I'm all excited. This is really good. That's how we like to have it. The room full and full of expectation and full of hope and full of celebration. So welcome everybody. My name is Walter Herzog. I'm the director of the Human Performance Laboratory. I'm just going to say a couple of words about the program and then let Dr. Benoneg introduce Brian formally. But I wanted to say a couple of words about the Human Performance Laboratory. So Dr. Benoneg came in 1981 from Switzerland to Calgary and built up this laboratory. And I always like to refer to our first lab behind the service area in the A block, little room with a force platform and a couple of cameras and not enough room to not really do anything at all. And really came on a prayer that we would get the 1988 Winter Olympic Games, and then we got the 1988 Winter Olympic Games, which then allowed, part of that was building the first 2 floors of where you're sitting right now, the Human Performance Laboratory. And then in about 2002, 2003, 2004, we built the second 2 floors, and that was from a CFI grant, about $14 or $15 million, I think, Brian. Brian was one of 3 people, together with Roy Gravel and Ron Zernicki, to actually write that CFI grant and make it possible for the additional top 2 floors. So he's responsible that you have a roof, over your head here. So I was here before Brian, about 4 years before him, so it's really a bit nostalgic seeing many of you that have been here a long time ago. I recognize many of the faces, and some I barely recognize, but they make me aware that I should recognize them, so sorry for all of that. But it makes me also think, oh wow, I've been here longer than Brian, so maybe I should be retiring too. But today is Brian's day, and I'm just going to tell you how this is going to work. So in a second, Dr. Nig will be coming up and formally introduce Brian, and then Brian will be giving a 45, 50-minute type of a presentation on, I have no idea what. We left that completely up to him. And then after that, we have prepared some refreshments downstairs on the main floor. So after the seminar, we slowly would go out and then just go down the stairs or down the elevator to the main level. And there we will have, as I said, some refreshments, and then also some of Brian's former colleagues, students, collaborators that would like to say a few words and tell a few stories, and I'm going to be really interested about those. So thank you very much, everybody, for coming. This is a great occasion. We don't let people get away and just retire without saying goodbye, and so this is the way how we do it, and I'm very happy that all of you could make it as well. And so I would like to ask Dr. Nig now to come up and do the formal introduction for Brian. Thank you for coming.
I would like to announce that this is a new record for the number of babies that are in this seminar. We've never had that many babies here. I'm very honored and pleased that I can do that introduction for Brian. As a matter of fact, it is interesting to see that Walter and I both have a pink shirt and Brian has a black one. I don't know what that means. But he has some white shirts too. Brian's academic career started at the University of Guelph, where in 1975 he got a BSc, and 4 years later he got a PhD from the University of Florida in Gainesville. Now typically a graduate student does a master's first and then a PhD. Now he was so sharp that he was just fast-tracked into the PhD, and in 4 years he got his PhD. Is that because of you? He then had a postdoctoral fellowship at the Queen's University, an assistant professorship at the Concordia University, and after that at the University of Saskatchewan, and then he saw the light at the end of the tunnel and came to Calgary. 1989 till 1996, he was an associate professor at the University of Calgary in the Faculty of Physical Education. At that time, that's the name of the faculty. And in 1996, he became a professor at the University of Calgary in the Faculty of Kinesiology. His research interests were mainly skeletal muscles with speciality in muscle fatigue, force modulation, and storage and return of energy. And when you look at Brian's work and Brian's research group, there are certain things that appear for an outsider always very interesting. He had graduate students that were completely different than the other ones. Very special personalities. He had once a singer. He had people that were very good in coaching. He had many different people that were very special. And this work here that I have written down that he did together with his graduate student, Jared Fletcher, running economy from a muscle energetics perspective, is a completely new way how to look at the question how to store and return energy during locomotion. And the effect was so that in the first week they had already 1,800 downloads. In the first 5 months, I had over 5,000 downloads. The publication was placed in the above 83% of all the publication of that journal, and one ranking had them in the top 5. So this is fantastic, and this has contributed, among other people, to the ranking of the Faculty of Kinesiology. Some of you may know that the Faculty of Kinesiology has been ranked 2 years ago as #1 in North America and as #7 in the world. And these type of things have contributed to that. As a matter of fact, the interesting thing is that that question of how to look at storage and return of energy, he has looked at that from a completely different point of view. He has looked at that from the point of view of how much can I gain and how much does it cost me? So very holistic. And I assume that you will talk about that a little bit, maybe not, a little bit. He had many awards and recognition. He had an outstanding supervision award from the Faculty of Graduate Studies of the University of Calgary. He was president and executive director of the Canadian Society of Exercise Physiology. He got an honor award from that society, and he was the chair of the National Advisory Council for Exercise in Medicine, between 2012 and 2016. Here, 1 year after he arrived, you see that young guy. You know, when I walk around and the dean, when she introduces a new faculty member to me, I always think these are students. And he looks a little bit like a student, doesn't he? As a matter of fact, there are other people here. Preston Wiley, Larry Ctate, Tish Doyle, Dave Smith, Walter with hair, Roger Jackson, myself with hair. Now, when you talk about Brian as a person, I always liked to see him, because when I saw him, it was always fun. He's always smiling, making a nice chat, Or when there was a party, he had once a student. I mean, that student did nothing else than giggle the whole party. And Brian giggled with her, didn't he? He was always very helpful, and it was always fun to be with him. Now, the title of his presentation is Reflections and Illuminations, but that's not the end of the title, because he's very modest. He always wants to share with others. So he says, Reflections and Illuminations, with a little help from my friends and students. Please welcome Brian MacIntosh.
Thanks, Benno. Very nice. So when I was asked what I wanted the title of this presentation to be, I had to think about it for a while, and I'm going to reflect back on my career, which, as you just heard, has been fairly long, and shed some light, not so much on the science behind what I've done, but on the process. How did this get done? And there's some interesting little stories that go along with some of the research that I would like to highlight. And of course, none of this could have been done without the help of my students and colleagues. So that's with a little help from my friends, and it's kind of Beatlish, so I thought I'd put it in there. And actually the picture in the background is, you'll recognize Bill here. Yeah, Bill's here. And Bill and I had the good fortune to go on a trip to Italy and do some cycling several years ago, and this was one of the pictures from that trip. So you've already seen this, so I'm not going to dwell on it. I would like to acknowledge that for much of that career, my wife, Dale, was with me. I dragged her from Guelph to Florida to Kingston to Montreal, Saskatoon, and here. And unfortunately, she passed away in 2012, so is no longer with us, but certainly somebody who kept me going and involved and supported me all that time. So I thought I'd just put a quick list of students up here. These are undergraduate students who worked at my lab at some time during my career, starting with some from Concordia University and University of Saskatchewan, and then the rest are University of Calgary. I obviously don't have time to tell you the research that all of them did, but a few of them I will highlight in the slides to follow. These are visiting international students, and I would confess there's a very strong Dutch influence here, and one of them is here with us today. She made the special trip to come and be here, and this is her floor sitting with, now she had a very unique way of doing it. She was a PhD student at the time, and she actually sent 2 master's students over ahead of her to lay the groundwork and get things ready, and then she came over and helped with the research for a while. She was here for 3 months, they were here for 6. Many of you will probably remember Liana and Ninka. These are the MCAN and MPE students I supervise. Now, we have this course-based master's program, which has changed over the years, but when it started in 1988, actually, and I was brought in to help support that program, the students had to do a project. So they were supervised to do a project, and many of my students actually published their work. And I think that's remarkable, and I'm going to highlight some of the work that these students did. But those are the MPE and MKIN students. I think it was, actually it must have been 2006, or no, it was before that they changed. It must have been in 2006. After that, they changed it so they didn't have to do a project, and the students weren't supervised, which is why there's nobody there after then except Colton, and that was because Colton came to me and wanted me to supervise his practicum, which is part of the new program. And we're hoping to get some publications out of that work. He's just started another graduate degree. These are my MSc students, again from Concordia, University of Saskatchewan, and the rest are all Calgary. And again, some of them are here. Meredith is here from Toronto, over here somewhere, yeah. And then PhD students, excuse me. So one of the things, I put this picture in to remind me to say that many of the PhD students actually helped supervise and control the undergraduate or visiting international students, or in some cases the master's students. So, and I think, everybody's here except for two, Reza and Dilson. And Dilson's the dean of the Faculty of Education at McGill, so he thought he was a little tied up to make the trip out here at this time. And then, of course, there's several colleagues that I've worked with over the years, and more in Calgary than anywhere else, but certainly in a variety of places. Sometimes I've gone there, sometimes they've come here. It's always nice to collaborate with international people and learn a little bit about life in other countries. It's always easier when they speak English than me having to learn another language, but it still works. So these are the primary research topics that I have dealt with over the past 30 to 40 years. In fact, skeletal muscle fatigue was the title of my thesis, my PhD thesis. And it has been a topic of research ever since then. You'd think I'd have it figured out by now, but apparently not. Again, so there's the common theme of all of the work is that it relies on skeletal muscles. And so it could be the contractile properties of muscle or energetics of muscle, or how muscles contribute to power output, which relies on the force-velocity relationship. But everything falls back to muscle. And I think of exercise physiology as the study of how the body supports muscles at work. So very muscle-focused. These are the undergraduate courses, and I just put these up to show that I've taught a lot of courses over the years, some of them several times, some of them only once. For example, somewhere in here, and I don't even see it. No, yeah, there it is, way down here. Applied Anatomy and Kinesiology, that was a fancy name for biomechanics. I taught the introductory biomechanics course one year. Go figure. These are graduate courses that I've taught over the years, and in this one I used a textbook by Alan McComas, which was a very good textbook, and the textbook was basically all about muscle. You'd think I'd like that, but actually I didn't like it very well because there were several things in it that needed to be updated, and I kept bugging let's go back up here. I kept bugging the publisher saying, when is he going to update this? And finally they actually asked him, and they came back and they said, he's retired, he's not going to update it. And I said, well, do you think he'd let me do it? And they said, well, let's see, we'll go ask him. And so they came back a couple of weeks later and they said, we'd actually already approached somebody else to do it. Would you be willing to do this as a collaboration with Phil Gardner? Well, Phil Gardner is somebody I worked with when I was in Montreal. We published together back then. That was back in the early 80s. And so it was a natural fit, and Phil and I worked on it together and published the updated version of that. I wanted to also mention that teaching often leads to research. You think you might get ideas from reading research and following what's being done, but quite often you read in a textbook something that just doesn't quite make sense. You go, I think that's wrong. I need to do a research project to see if I can support this or if something else comes out of it. So several of the research projects I've done have been basically trying to address things that are known well enough to be in a textbook, but that I don't think are right. So need to look at them. And actually, caffeine as an ergogenic aid was one of those. It was taught for years that caffeine helps physical performance by mobilizing fatty acids and preserving glycogen so you can exercise for longer at a higher intensity. And so I'm going to tell you a little bit about a project that dealt with that. And the lactate minimum test was a test. Now this was more research-based than out of teaching, but it was a test that when I first saw the paper that described this, I thought, that is brilliant. What a great idea. And then over the next 4 or 5 years, somebody from the UK published several papers saying this is a terrible test, it's no good, don't use it, and here's why. And in my reading of their work, I thought they were doing it wrong, that's why it wasn't working. So I had to do a project with Shane and show that if you do it right, it's really a good test. And then the energy cost of running is something that we've already heard a little bit about from Benno. It has been common for decades now to measure the economy of running not as an energy cost, but as an oxygen uptake. And so it's expressed as milliliters of oxygen per kilometer per kilogram of body mass. And I've always thought that's silly. If it's economy should be an energy cost, express it in units of energy. And if you go back through the literature, the reason that it was expressed as an oxygen uptake was because exercise physiologists are very blinded and focused on oxygen uptake. That's one reason. But the other reason was people said, well, the amount of energy you can get per liter of oxygen varies depending on what substrate you use. If you use carbohydrate, you get a certain amount of energy. If you use fats, you get a different amount of energy. And so the notion was we should express it as oxygen uptake because that's what we're measuring and that's more real. And I thought, well, if you get a different amount of energy, maybe you should express it as the energy cost rather than oxygen uptake. So we'll get back to that a little bit later. So this is the 2 books that I've been involved in publishing. One of them was with Benno and his colleague Joachim Mester. And then Phil Gardner and I did the updated version of the skeletal muscle textbook. And Alan McComas is the 3rd author there. He read through it all and approved it. And he said, "You're just putting everything we know about muscle in this book." That was his comment on at the end of the edits that went into it. And this is Phil Gardner in Rhodes. I cut John out of the picture. He was over here with a similar glass of beer. So this is the caffeine story. And this the person who did this was Bridget Wright. She was one of my MPE students. So a course-based student did a project, and she did the whole thing. She did the ethics approval. She recruited her subjects. She was at the pool doing the tests. She had somebody there to help her take blood samples. And she did the whole thing, and it ended up not significantly different. And so we looked at the data, and we looked at some of the recent literature and said, well, wait a minute. You used 10 milligrams per kilogram of body mass caffeine. That's a pretty high dose. So I don't know if you can put that into perspective, but a regular-sized cup of coffee, not the venti or even grande size, but a regular-sized cup of coffee has about 100 to 150 milligrams of caffeine in it. And so if you weigh 70 kilograms, you're talking about 2 milligrams. So you take 5 of those, and now you're up to the 10 milligrams per kilogram body mass. So that's the equivalent. Not that you should take your caffeine in coffee if you want it as an ergogenic aid. That's not the best. Anyway, Bridget looked at this and saw the negative result with the high dose of caffeine, and we thought we could do it again and use a lower dose. So she did the whole thing all over again. And this time there was a significant difference. And there's the result. You can see this is the time to complete 500 meters for the first 500, the second 500, and the third 500. And the top line of the bar is without caffeine, and the solid part is with caffeine. So each 500 was swum faster with caffeine than without. It definitely was an ergogenic aid. But A 1500 is over in about 20 minutes. Most of the people here were triathletes, and that's about the time they were taking to complete 1500 meters. Glycogen depletion is not an issue for something that lasts 20 minutes. Therefore, caffeine helped, but not by preserving or preventing the use of glycogen. There must be some other mechanism. And she actually took blood samples as well, and we showed that when they started the 1500, that if they had caffeine an hour earlier, their potassium concentration was lower. And my colleague Jean-Marc Renaud would say, hey, potassium causes muscle fatigue. So we think that might have been a factor contributing to the benefit of caffeine as an ergogenic aid. I also did a lot of research on power output on a cycloergometer. And Arnie Nutting was another one of my course-based master's students. And he had the idea of putting sensors on the resistance belt of a Monarch's ergometer so we could actually measure the resistance continuously during the test. Now, he was in the lab, he put these sensors on, he tested it, he did all of the control and background stuff that you need to do before you can actually use it for research, and then he decided that for his research project he was going to do an exercise program for fibromyalgia, completely unrelated, but others went on and used that bike productively. But I wanted to point out that that study that Arnie did has 336 citations, which is a lot. So it's one of my most highly cited papers, and it was on a field of study that wasn't my primary area of research, but with Liam Martin, who is the first author here. Liam, I think it was the one who convinced Arnie to do this project, and it was not only picked up by a lot of other researchers who cited the work, but it was actually developed into an exercise program. So that I don't know if you still can, but for a while you could actually register for a program here that was an exercise program for people with fibromyalgia. So very quickly it went from research to application. So here's Arnie's idea: put these sensors on the resistance belt of the ergometer so you could actually measure the resistance. And one of the people that picked up on that was Shirley Bryan, who was also a course-based master's student. And she was evaluating the Wingate ergometer built by Monarch. Now, before they built this ergometer, the way that a Wingate test was done, and a Wingate test, for those who don't know, is you get on a cycloergometer and you go as hard as you can for 30 seconds. And the idea is, let's measure how much work you can do in 30 seconds, and that we'll call that your work capacity, or anaerobic work capacity, because it was thought to be using predominantly anaerobic energy. And the way you do it is you get somebody on a bike. Now, if you remember the old Monarch ergometers, like a lot of the fitness ergometers back before they had electronic ergometers, you had to turn a button to adjust the resistance, or turn a little wheel. And so you get somebody on the bike and you tell them to go just as you start turning this to get it up to the right resistance. And everybody had the resistance estimated for them. So it's an individualized resistance. And it took several seconds to actually get it there. Well, John Holash, when he did his master's degree, showed that if you take more than about 3 seconds to get to peak power output, the value will be less than if you can get there sooner, because you fatigue in that time, 3 seconds. So in the time that you're adjusting the resistance, they're already fatigued. Well, Monarch thought they overcame this problem by creating a bike where you could flip a lever and the load gets applied to the belt. And so it was instantaneous. But the problem was you could put the weights in a little pan, and that was the load, and it was assumed that the belt took up, that the load was the full resistance on the belt. And so with this measurement of resistance, measuring the force on the belt in front and behind the wheel, you could see what the difference was. Well, if the back was 0, then the resistance was equal to whatever the load was pulling on that belt. And we showed that in the Monarch ergometer there was always some tension back here. So it wasn't the whole load. And the other thing that we found was people reporting using that bike had unusually high power output. And it was because they were getting, they were assuming that the load was equivalent to what the weight was, but it really wasn't. Now, that was published, I think about 2002. And several years later, I was sent a paper to referee. And they did exactly the same thing, got exactly the same results. And I looked at it and I sent it back to the editor who had sent it to me, and I said, you know, I really can't serve as referee for this because they've basically duplicated what I did and published 5 years ago, and they don't even acknowledge my work. So I sent it back, and of course they sent it back to the authors, who then revised it, put a reference to our work, said how great it was because it matches their work, and then they got it published, but I wasn't the referee for that. So you can publish work that is just duplication of work that's already been done. We also did several other papers using this ergometer. Paul McEachern looked at a 30-second test and said, if you pace yourself for 30 seconds, can you get as much work done or less or more than if you go all out right from the beginning? And it turns out that it's exactly the same. And Peter did a nice little study on a measurement of what we called short-term work capacity, because there was a lot of fighting against the use of the term anaerobic when it came to anything in exercise physiology, with good reason, because anaerobic, if you look up the dictionary meaning, is in the absence of oxygen. Well, we don't live if there's no oxygen, and therefore we are not anaerobic, and yet a lot of exercise physiologists still use the term anaerobic, talking about many things. And Min-Han Kim also did a study looking at fatigue and how optimal resistance changes. So this was the paper by Shirley. Not surprising, not a lot of citations, but not bad. And this is the lactate minimum test. So I mentioned that earlier, and I want to say that Krista is here, and Krista was involved in a lot of these studies that went on in the early 2000s. The theory behind the lactate minimum test is that if you do something really vigorous and get your blood lactate up high, and then you do an exercise test where you start at a low intensity and keep increasing the intensity, as long as your intensity is below the intensity where you would begin to accumulate lactate, then lactate would go down. And so lactate will decrease, but when you reach the intensity that you start to accumulate lactate, then it starts going back up. So it's nice and simple, direct, and it works really well, in spite of that group from the UK. And a nice picture of Shane and his voice from several years ago. And there's Krista, and Krista was actually working as my technician. Krista did the course-based master's program as well. She wasn't actually one of my students, but did some work with me, and then became my technician for several years. And one of the things that I had her work on was a review paper on the anaerobic threshold. So we're starting to use this anaerobic term again, but we redefined it. We said, if you're going to use the term, think of it not as in the absence of oxygen, but without the use of oxygen. And if you think about it that way, then it makes sense to use it in the work that exercise physiologists do. And so I don't know how long it took us to write that paper, but it was quite a while, and we went back and forth with it many times, editing and then adding to it. I don't know, it's probably one of the longest papers published in the Canadian Journal of Applied Physiology, and it is my most cited paper. And I put that little picture of the phone up there because the day it actually came out, I got a phone call from a colleague in Virginia who said, Brian, great paper. I wish you'd have come out with this 10 years ago. I want to use it in my teaching. And it actually has been adopted in many teaching programs. and we use it here for the students when they do their anaerobic threshold lab, at least the grad students, maybe the undergrads as well. So that was anaerobic threshold. I mentioned that lactate, oh yeah, there's a few other people. That's Dilson and his wife, and John and Barbara, and Krista, and me. So this is blood lactate concentration over time, and blood lactate will typically increase when you start to exercise. But if the exercise intensity is reasonably low, it'll either fall back down like this, or stay reasonably constant. And if you get to the highest exercise intensity where it will stay constant, then you're at what we call the anaerobic threshold. And that's basically how we defined it. If you go above that, you'll see that lactate increases. Now, back then, we didn't know a lot about the way lactate increases, and we've got it going up nice and linearly here. Keep that in mind, because I'm going to come back and talk about that later. Now, I will say that lots of people had done research looking at anaerobic threshold over the years, and this was published in 2003. And so this graph was showing the many different ways that people tried to estimate anaerobic threshold. They called it anaerobic threshold because they thought the body became anaerobic when you're producing lactate, but you're always producing lactate, so I know that's not true. So in this, blood lactate concentration is shown here over time during an exercise test where intensity keeps increasing. And the dark spots here are the blood lactate concentration, and you end the exercise here, and then in recovery, lactate continues to go up sometimes and then comes back down. And some people said, let's just make it easy, we'll call 4 millimolar lactate the anaerobic threshold. That's the easy way out. It's very objective, but it doesn't mean the same thing for different people. Other people looked at this and they said there's a nice linear increase, and then all of a sudden it changes from linear to something else. And so they said, let's call this the anaerobic threshold, because that's where things change. Some said, well, you can get a linear here and then a linear here, and maybe this is the threshold. So you can see there were lots of different ideas, and nobody really knew what to do. And we thought we can solve this by saying it's the highest intensity of exercise for which aerobic metabolism can actually satisfy all of the energy needs of the exercise. And once you get above that threshold, there must be lactate accumulation, because there will be sustained anaerobic metabolism. That was the whole basis of the review that we published. Actually, I'm going to skip this just because we don't have enough time to deal with all of it. John Horton did his MSc degree with me. I think John actually started with the course-based program. Where is John? Is that correct?
That's correct.
And then you decided, no, that's not for me. I'm going to do a thesis. So he came to me, and he wanted to do a thesis, and he was going to, he was a golfer. So he wanted to do research with golfers. And one of the things that he decided he had to do was to measure EMG. So I gave him a project to do just to learn the EMG and get familiar with, putting the electrodes in the right place, and or getting the skin ready first, and then putting the electrodes on and measuring and calculating everything. And we looked at the paper at the end of it and said, or looked at the results and said, this is kind of interesting, let's publish it. So we did. So John's practice project ended up with this publication in a pretty good journal, and there's 217 citations now, so apparently other people think it's pretty good too. I will say citations are an interesting measure, because it could be because it's bad, but I think it's because it's good in this case. And a lot of people have actually used the concepts and ideas from this paper. And this is what he found. He measured EMG in several muscles, and he quantified it in terms of the magnitude of response. Now, EMG is essentially you stick electrodes on the skin, and it detects activation of the muscles under the skin. So you kind of know where the muscles are. You can put the electrodes right over individual muscles, And he had measurement from 7 different muscles. And he quantified the magnitude and added them all together and then averaged it across the 7 and ended up with an EMG signal that's representative of the muscles needed to ride a cycle ergometer. And these 4 lines represent different power output, where the bottom one is 100 watts, this is 200 watts, 300 watts, and 400 watts. I will point out that the anaerobic threshold is typically somewhere in here between 200 and 300. Now, what he showed when you added them all together is that what he did was he had people ride at a different pedaling rate, generating 100 watts at 50, 60, 80, and 100 revolutions per minute, and 200 watts at 50, 60, 80, 100, and 120 revolutions per minute, and so on. And the really interesting thing that came out of this was, if you're going at a low power output, you can do it with the least amount of muscle activation if you go at 50 revolutions per minute. But if you're going to go at a high power output, the least amount of muscle activation occurs at close to 100, maybe 90, 95 revolutions per minute. And you could actually take a line and go right through here, and it shows that as you increase power output, the minimum EMG needed to cycle at a given power output is increased, or not at a given, but as power output increases, the cadence increases, the cadence that gives you the least amount of muscle activation. Now, my general thought at the time was that if you have to use more muscle, you probably need more energy. And it turned out several years earlier, somebody had looked at oxygen uptake at 100, 150, 200, 250, and 300 watts, and the same range of pedal frequencies, and almost the same graphs. I mean, one's oxygen uptake, which reflects energy, and the other one is how much muscle you need. So clearly there's a nice relationship there. And then this was his thesis, and it turns out John was pretty good at getting citations. He's up to 119 now for this one. And this was done with Dave Lindsay, who's also here. Now, calculating active force. This is something that wasn't what we were looking for when Meredith did her thesis on the effects of muscle fatigue on the force-length relationship. But she very diligently did all of the experiments. She had control experiments and different ways of causing fatigue, and looked at the consequence in terms of the force generated at different lengths. This was all in a rat muscle preparation, which has been kind of a mainstay of research in my lab over the years. And so here's one of, this is the paper that was published not because it was part of her thesis, although it did become part of her thesis. It wasn't the originally planned study. We looked at the results and we thought, we can't explain this, there's something wrong. And so Meredith showed me, first of all, a control graph, and she had several graphs like this. So this was one where the force that the muscle could generate, and actually, so the dark ones here are passive force, which is the force before a contraction. And then you have the peak force, and this is before and after a period of time. In the experimental group, we caused fatigue. In the control group, there was just a waiting period. Nothing was done. And this was one of the control experiments. And it shows very nicely that the peak force doesn't change, but the passive force did. And if the passive force changes, and you want to know what the active force is the peak minus the passive. And so it would look as though if we subtracted this from this to begin with, and then after a waiting period, we subtract this from this, it's getting bigger. Why would the contraction force get bigger after a waiting period? It's not warm-up. Ilya did that study and it doesn't work. I shouldn't say it doesn't work. It doesn't work if you do too much. So it turned out that every time we weighted and did a force-length relationship, or did the measurements for a force-length relationship, passive force got lower. And so we decided maybe we're subtracting the wrong force when we calculate active force. And so over here is a contraction, and this is a submaximal contraction. The stimulation frequency in a rad is 50 per second, and it causes force to rise and fall with each activation. In our muscles are slower, and if you stimulate at 50 per second, you get a nice smooth contraction, but not with rats. So this contraction has a passive force up here. And so normally you would calculate active force, and it's the difference between here and the highest bump in the series of bumps across here. And so the blue line there represents active force in the traditional way of calculating it. But we thought maybe passive force is changing during the contraction, and that active force is this. And we did a series of experiments and showed that that actually made a lot more sense. We got more consistent control measurements, and the other thing was that the results in fatigue now made sense. Whereas if you use the traditional way of calculating active force, it just didn't make sense. And this is one of her papers from her thesis, I think. She had 3 papers from her thesis, and there's Meredith and Ilya and Stan. And I wanted to say that Meredith also introduced me to Jennifer, who was here, but she stepped out. There she is. Who helped Meredith with some of her experiments and did a project on dantrolene. Actually, I wanted to say when we discovered that people were subtracting the wrong force, and we had to correct, she didn't have to do all her experiments over. She had enough data and had done it well enough that she could go back and recalculate the active force the right way. And so she did that. A lot of extra work, but not nearly as much as if she'd have had to do the experiments over. So Jennifer did this study on dantrolene, and dantrolene is a drug that inhibits calcium release in muscle and makes it weaker. And so we wanted to know if dantrolene would actually change the force-length relationship in muscle the same way that fatigue did. And it turns out that it did. So it suggests that in fatigue, the reason that we have fatigue is because less calcium is released in the muscle, just like dantrolene would cause. Dilson came to my lab and did a series of experiments on potentiation, which is enhancement of force due to a prior contraction. We got this strange question once on a grant application. I had this article cited as one of the things we've done, and they said the feedback was, why would you publish in such an obscure journal? And well, the reason we had was actually quite logical. Dilson was Brazilian. He was finishing his PhD with me, and he had to go back to Brazil, and he thought that was one way of getting his name in the Brazilian literature so that it would make it easier for him to get a job. The other reason that we chose this journal is this was one of the first open access journals. Open access journals are all over the place now, and this one was free. You didn't have to pay $2,000 or $3,000 to get your research published. So it was really a good place to put it. And it now has 403 citations. So lots of people have seen this article. And these are Dilson's publication with me. Now, Dilson went back to Brazil for a couple of years, and then he came back to Calgary. Many of you are aware of him having been here for a few years with Walter. As a postdoc. But this is what he did just as part of his PhD. Now, Ilya did a study on warm-up. Ilya's at the back. And one of the remarkable things about this study, I mean, the results were interesting, and they did stir up a lot of attention. But we invited the media in to talk to Ilya about his research once we had the paper published. And so it got into the national news, and local newspapers and news magazines, and there was a half-page article in the New York Times. They actually called me and interviewed me. I was at the American College of Sports Medicine meetings at the time. Huge impact on social media. So this is one of those papers when Benno was talking about the altmetric rating system. This one is way up there. It's in the top 5% as well, just like Jared's paper. And actually, if you Googled more is less, which was the first part of the title, one of the referees didn't like that, but the editor actually stepped in and said, no, it's okay. And so if you Googled more or less, you've literally got thousands of hits related to this research study. So it was really popular. And basically what he showed was, if you do the warm-up that most track cyclists do before a sprint event, you do not perform as well as if you did our warm-up, which was basically half as much and lower intensity. So then we get to the energy cost of running, and you've already heard a little bit about that because Benno mentioned this. Jared came to me from the University of Manitoba and wanted to study the energy cost of running. Energetics and muscle contraction had been part of my research all along, but I'd never looked at the energy cost of running in my lab. So this was kind of interesting, and it kind of uses my knowledge about muscle and what's going on. And one of the first things that I wanted him to do was to prove that there is a reason to calculate the energy equivalent rather than leave it as an oxygen uptake. And so he did, and that's what this paper is about. And not only is it an interesting paper, but it's got over 200, over 200 citations, and it has actually made a difference. People now know that they're supposed to put the energy equivalent in energy units, not just oxygen uptake. So most of the papers on the energy cost of running that have been published since we published this have actually used the joules of energy rather than milliliters of oxygen. And this is the graph that showed why. So the top graph shows oxygen uptake at different speeds of running, and there was no significant difference. So you could run faster. Now the oxygen uptake is expressed per kilometer. So it's saying that you use the same amount of oxygen to run a kilometer, whether you go relatively slowly or relatively quickly. The lower one is the energy equivalent. So it's the caloric unit cost, kilocalories per kilogram per kilometer. And that was a significant difference. Now, the large variability is individual variability, but each person in the group increased a little bit each increase in speed. So it was significant, and it pointed out the importance. If you want to be precise, you really should use the energy equivalent, not just oxygen uptake. And then this is the review that Benno mentioned. And this was a reviewer comment. Actually, and in this journal they publish who the reviewer is, so I know who actually said this. Roger Cram did, and biomechanists will recognize that name. He said this review is unlike any of the recent reviews. At first he didn't want to even look at it because he said we've had enough reviews on energy and energy costs of running, but he said he liked the muscle perspective. It adds significant value. So that was a pretty nice comment from Roger. So remember I said the increase in lactate was at that time thought to be linear when you go above anaerobic threshold. So above the anaerobic threshold, there is a slow component of oxygen uptake. Oxygen uptake continues to rise when you exercise for beyond 3 minutes at an exercise intensity above the anaerobic threshold. And it has always been thought that that increased oxygen uptake represents increased energy. So here's this battle between energy and oxygen uptake again. Well, I've already said that when you go above anaerobic threshold, some energy is provided by anaerobic metabolism leading to accumulation of lactate. And so when you measure oxygen uptake, you're not taking into account all of the energy that's actually being used for that exercise. And so along came Jess, and Jess is here today somewhere. There she is. Unfortunately, she's here today. She should be at the World Championships, but she's injured her Achilles tendon. So this is what she found. Oxygen uptake, if you're exercising above anaerobic threshold, after about 3 minutes continues to rise, and that's what we call the slow component of oxygen uptake. And for years now, everybody has assumed this means the energy cost of the exercise is increasing. And so we published this paper and basically said that blood lactate accumulation decreases during the slow component of oxygen uptake without a decrease in muscular efficiency. In other words, oxygen uptake is going up because lactate production is going down and the energy cost of running is staying the same, except for the increase needed to support an increase in ventilation. You breathe more as you exercise longer at these intensities, and that does require a little bit of extra energy, but that's only about 20% of the increase can be accounted for by the increased cost of ventilation. So the rest of it is not an increase in energy cost. And so there's no reason to think that the energy cost of exercise is increasing when you have this increase in oxygen uptake. And this is my retirement project, a new book which will be an online textbook of exercise physiology, open access, so anybody can get it. I'm not going to make any money on this. There are 20 chapters, and I've talked other people into helping me with this. Half the chapters are nearly ready to publish, so I'm hoping within the next month or so we can actually have this online. And it will have an extensive glossary. This is one of the things that has taken a lot of time because we're actually linking each word in the text that is defined in the glossary to the glossary so that people can put their cursor on it, click on it, and get the definition right away. And we think this is a value of online or digital publication, and so that's what we're doing with this. And the nice thing about the university press is that they're actually going to provide a hard copy to anybody who wants to pay for it at cost. So it's not going to be a $300 textbook like some of the exercise physiology textbooks are. That's me, by the way, just in case nobody picked up on that. A few years ago. And I also wanted to say thanks to my extended family, most of whom, if not all of whom, are here. I don't think Aspen's here, is he? But the rest are here. So I got married again a few years ago, 2.5 years ago, to Sandy, and she has 4 kids, and I have 2, and between us we've got 7 grandchildren. So that's also my retirement project. So thank you for listening.
Thank you, Brian, for a beautiful overview of a long and successful career and so many accomplishments. Something to be really proud of. We were struggling a little bit whether or not there should be questions or not, because there's probably a lot of non-scientists and little kids here, and so I think I'm going to make a suggestion that non-scientists in the room are allowed to ask a question if they want, but all the scientists should ask Brian privately because he's here, and so, but or if you have been out of science or not anymore. So if any of you have a question that's more a practical question, maybe, then we'd love to have that. What do you think, Brian?
Yeah.
Yes.
I was interested in the study you did about the treatment for fibromyalgia. Could you talk a little more about that? I mean, how effective the treatment was it? I know fibromyalgia is kind of complicated, but
Yeah, it is. And so fibromyalgia is a condition where people feel sensitivities in certain body parts or regions, and so it bothers them to move, but it bothers them even more to be pushed or poked at these tender points. And so it's very difficult to diagnose, and it's
we tried.
and it's also very difficult to evaluate whether or not some treatment is working for it. So what we did in this project was we had two groups of fibromyalgia patients, and they were evaluated by the physician, Liam Martin, and they were evaluated for physical fitness as well. And then we put half of them on an exercise program where they came in and did a group exercise program 3 times a week, and I can't remember whether it was for 10 or 12 weeks, something like that. And at the end of it, we evaluated their fitness again, and also had them evaluated by Dr. Martin for tender points and that sort of thing. So there was a score system that he used to evaluate the tenderness. And that decreased in the group that got the exercise program, but not in the group that did the stretching program. We thought it was important to do a control group that, first of all, didn't do exercise, but did do something where it was a social event that they were committed to over the period of the time, and so it was an appropriate control group in that way. And that group did not improve. Of course, then all of the ones that did that wanted the exercise program, so we did it for them too, but that wasn't part of the publication. But there was a score that they actually decreased on.
Maybe just to add a comment here, Brian was one of the very early ones to do that, using exercise for certain interventions for disease. And many of the people in the faculty now have taken that up and work on all kinds of exercise interventions for cancer and musculoskeletal diseases and a whole bunch of things. And that really was one of the very early studies that really motivated other people to do that in this faculty and elsewhere. Any other questions from a layperson, or how should I say that?
You have a long and storied career. What aspect of your career has given you the greatest amount of satisfaction?
Boy, that's a tough one. I think most of my students would support the notion that I really enjoy the getting in the lab and doing the experiments, and that's something that over most of my career I've done and been part of. I think that's it. It's the process, more so than even the results. It's always nice to look back and realize that you've made a difference in something. And I think the exercise program for fibromyalgia was one. The calculating active force is one, because it's actually been adopted and others have picked up on it. And of course, the energy cost of running is something else. And so I should use a little story. The other book, the what that I didn't really mention, was the Biomechanics and Biology of Movement with Benno. So Benno and I were editors with Joachim Nestor. Well, that actually started as a much bigger project. It was going to be a 3-volume encyclopedia of sports science. And Benno and Joachim were working on it. I wasn't part of it. And Benno actually came to me one day and he said, if we want somebody to write a chapter on fatigue in this encyclopedia, who would you recommend? And I said, well, Benno, that's what I've been studying for I don't know how many years now. I would write it. And he said, well, all right, let me think about that. And he went away for a couple of weeks, and he came back and he said, Brian, my colleagues in Europe don't even know who you are. He wanted somebody who was known. Well, from that time until now, I think things have changed. I am known in Europe, and not only in exercise physiology, but also in biomechanics, because I have published some work. Well, I think I've got two publications in Journal of Biomechanics, so you can't get any more biomechanics than that. But certainly the energy cost of running is something that the biomechanists and the exercise physiologists share an interest in. And so I'm well known for that work here. So that has been a change over the years, and something that I do appreciate.
Great. I see a lot of children here that might have a question. Or not? No questions from the children?
It's all clear, right, Alex?
Yeah, all crystal clear. So I would like to thank Brian very, very much for a beautiful talk, a beautiful career, and And let's give him a hand first before I go on. Very well, there's another question there.
What are you going to do now with all your free time?
All my free time. Yeah, you know, I'm busier now than I have been in the last several years. The book project is something that's going to take a lot of time. I am still doing research. I'm still funded by NSERC, and so I do have some lab space here, and I will continue to do research. And I have one graduate student sitting over here, Keenan. And although he's just about done with his master's degree, he has promised me he'll do a PhD. So I could be around here for several more years. But traveling and photography are things that are also one year.
There's great precedence in this lab for people retiring and sticking around forever. As I always said, I'll be leaving this lab before Benno will. So with this, I would like to invite all of you to go downstairs. If you don't know how to get out, just follow some of the people who know. We have a little bit of refreshments downstairs, and then I'm going to be really interested about hearing some of the real inside stories about Brian that will be talked about by some of his colleagues and friends and former students. So thank you very much again, and please join us downstairs for the refreshments.